All right. Here we are. Let's see what we can fucking figure out. What's on the menu today? Well, this beautiful PC right here. We're going to test out a couple things right now. And first off, I think we should probably figure out what we're going to do. So how about we're figuring out how to program some fucking C programming on a computer from 1985. And that's pretty much it. So we're going to get started and see what the fuck happens. So a little bit of background here. What am I doing exactly, right? Well, I found this old computer, actually over there, but it was actually in my grandmother's basement, my grandma and pop. It was in their basement, and well, I decided that I would take the Franklin Ace and the other computer. So this was the other computer, the Amdek computer, because this one interested me a hell of a lot more than the Apple II, because the Apple II was fun and all, but you know, it's an Apple II, you know, you can do certain fun things on it, but this I could fuck around with and figure out what the hell to do with. More coffee and let's fucking get to it. All right, come with me, guys. We're gonna fucking write this down on our whiteboard here, just so that way we can make sure we know what's popping. I lied. My whiteboard, I didn't clean it. All right, so we're gonna use tried and true pencil and paper here. So pencil and paper, not bad. So let's get it going. So what are we gonna write? Well, first step, we're gonna write down the name of our project. But number one thing is I just wanna walk you guys through real quick. What are we doing on this channel? Well, we figure shit out. I document how I figured it out. I let you know what I did to figure it out, and that's it. So first thing we gotta do is always gotta write out our plan, our strategy, and we have to figure out what exactly we're trying to do here. So the number one thing is I haven't touched this computer in a fucking minute. So let's write down Wyse PC, and what do we have to do? Check that it's still powered. Then we need to make sure boots to MS-DOS 5.0. Note, I say 5.0, should be running DOS 3.10. I actually have the DOS disk right there. This floppy disk right here. Oh shit. Oh, great idea. Great idea. Shove all your fucking Warhammer figures there. Man, I really have a lot of shit. I gotta get back on it. I'm trying to program a game right now. I'm trying to program a bunch of shit. Flash the game. Where did I put it? Oh yeah, here it is. MS-DOS 3.10. And here's the GW Basic, MS-DOS, and Amdek sponsored. This is an Amdek computer. Fun fact, it's technically a Wyse PC Plus. Or an IBM PC Plus clone, which is pretty neat. But as it says, so we're going to check power. We're going to make sure it boots into MS-DOS 5.0. We're going to launch Turbo C. We create a sub branch. So usually when I try to like plan these things out, I create a sub branch to things that kind of like, you know, go hand in hand. And I said check power because check power is more physical. Boots to MS-DOS, more physical. Not physical, but digital. So I could put like a dig fizz in there to categorize what we're gonna do. We're gonna launch Turbo C, verify we can compile, verify we can include the standard C libraries. Why? Because I gotta make sure that my paths and my systems in the system XE bin are good. Regardless, let's get to it. I mean, and then that's it. And then pretty much I'm going to walk you guys through KMU, which is the virtualization machine in Linux. That allowed me to get this XTCF card from Texelex, shout out Texelex, or a compact flash card that you normally use in like a camera. You know, a camera or digital camera, you would use this compact flash card, but turns out you can format it to be an old MS-DOS boot partitions. And what does that entail? Well, I've got a plan. I think we can make this do software rendering. It's not a 386 processor, so it's not going to be able to play Wolfenstein, so to speak, but we should be able to get something around the lines of, I'd say, Alchemeth, the Dungeons of Doom, Ultima Zero, as people like to call it. I really think that we could do something Ultima-esque, because those games are programmed on the Apple II with far less RAM. We've got 640 kilobytes of RAM, which is a lot. This came with the big bad thing. I think later on down the line, maybe I could use my FPGA to actually extend this RAM and then connect it into these slots, because I think that'd be a fun project to figure out how to do that. That's gonna be a bitch and a half, but you know, we'll figure it out when we get there. For now, I always like to say, let's just start simple, and that's it. So you're gonna see up here, so it should be doing something. So power's on, I've checked power. Yeah, oh yeah, it got knocked out. All right, so got knocked out when I moved a bunch of shit. Let me just, yep, there you go, guys. All right, so it says disk bad, right? So I'm gonna walk you guys through this real quick. So what is this Phoenix RAM? I don't know, fuck it, I'm not gonna stores all the things and set it to a default state so that way it can load it. But what I did is I just circumvented that. Basically, I fucking snipped that shit like a fucking vasectomy and injected some new shit into there and basically did a oil change of the hard drive and the boot partitions. So that XTCF card is actually going to have its own custom BIOS, and you're going to see that right here. See how it says XTD Universal BIOS or XTIDE Universal BIOS? That's XT for the platform XT, and now it's going to boot into C. I hope this works. We're good. Our RAM is good, and we're in C. You can see it right here. That's C. Yeah, you can see it right here. So we're going to go boots to MS-DOS, and we could even double check by typing version. And sorry, I forgot. It's just var. MS-DOS version 5.0, so we know we're good. And then the next test that we're going to do is we're going to type in dir. So you're going to notice something. It's going to stop because it's thinking. Now, the main question is why do you think it's doing this? 5 seconds, lock in your ears. I'm just kidding. You're fucking watching a video. My theory, I don't know why, but my theory is it's actually trying to read the entire file system of the 512 megabytes that I have in there. And it doesn't, honestly, not bad. See, because it does eventually go into there. And what you're going to see here is I have a bunch of files and folders. We're just going to do turbo C, TC for short. Why? Because I added that to the path environment variables. So if we do edit auto exec and then .bat, I can show you what I changed. See? So you have at echo off, and that's just normal, like normal thing, and then prompt $P, $G. Once again, normal. The only thing I added, and I actually removed a couple things. Those of you that are notoriously good at MS-DOS 5.0, you would actually realize that this right here, I added this, of course, not this. This is normal. It needs to know where DOS is stored in the partition itself, so that way it can boot into the operating system and you can have fun things like this. But I added, so I created a folder, I put TC in there, and in the QEMU, or how I did the virtualization, so what I did first was I pretended that my Linux machine was an MS-DOS computer, and that CF card, I was formatting it to work with MS-DOS. Because a lot of these things, you don't actually need a hard drive to run anything on these computers, really. Because you load it in, it loads in, you could do all your shit on that, you pop it out, you could do something else. It all reads from this floppy disk drive. My floppy drive is semi-working. It doesn't really, it's not very reliable. This hard drive is ridiculously old, so we're not gonna fucking, I don't think I can recover that. I mean, we could try, maybe, who knows, you know? It could be pretty cool. Regardless, we got this, I added the path, and then there's a whole bunch of other crap here, and MS-DOS 5.0 is pretty neat because, little goofy goober here. But, you know, so I actually got rid of all that shit because this computer cannot support it. But I wanted to run Turbo C, which works perfectly on MS-DOS 5.0. And that's pretty much it. I just told it not to boot all the extra shit because it doesn't have the same amount of RAM. Now we're good. So you gotta, let me tell you, these guys that used to do this shit were fucking nuts. But that's a quick branch off. Now we're into Turbo C. Turbo C works. So we're gonna check that off. Now I already have a test program that I kind of wrote, but so we can load it up, and I just like to search. It just allows me to search my entire thing. I go to projects, and here's matrix 1, here's test.c, so we're going to load test.c. Now, this actually is going to check off too. If you guys aren't familiar with C programming language, once again, this is not me trying to teach you guys shit. This is me just saying, okay, I used to program in C a lot back in the day. And, well, not back in the day, what am I, fucking like 80? huge. Compact or large? Large. Because I'm a large guy. I'm not that large. Well, actually, I don't know. Maybe I am. Who's to say? All right, whatever. So what we're going to try and do right now is I've just been doing a bunch of random research and shit because I was like, well, yeah, it's all fun and games. Like I could plot a pixel on a computer in a window in the command line terminal or anything like that. But then I was like, oh yeah, I'm quite literally programming this on a fucking computer from 1985. And what's the caveat of 1985? Oh, you actually have to know the fucking hardware that's in your computer. So that's going to be pretty baller. So you actually have to know your hardware that's in your computer. So you have to understand the CPU, its registers, its memories, how it's going to address certain things, which ones you can use, how to access your register. And with the 8088, it uses a 16-bit offset from what I've gathered. So whenever you want to access any other kind of RAM or any sort of memory, you're actually going to use some sort of pairing. So it's going to be that direct address plus, or that offset shifted 16 bits. So it's going to be a 4-byte shift. So it'll be interesting. We're going to see how I could do it with the 8088, and then this is CGA graphics, and as you can see, it's an amber screen. So I'm going to use mode 6 because I don't have color. So it'll be interesting to see what we can do. But first thing we got to do is just get our unsigned. We just got to do the row half, some random things in Turbo C, mainly just the offsets. We have to get our bank offset, or byte offset, the bit index, and the mask. And the mask is just going to be one bitwise shift to the index that we're going to choose, and the bit index is going to be 7 minus X ANDed with 7 or 8. Technically, I think. I don't know. Don't quote me on this. I'm not the guy. I just Googled a bunch of random shit. I found a bunch of random documents. I put it into a bunch of random fucking compiler thingies, LLMs, and it spit out some stuff. I kind of understand it. I actually have a textbook that I found that details the 8088, 8086, the 8486, and the 8386, all the way up to the Pentium 4 Intel processor line, which is kind of crazy. So we're going to be definitely taking a look at that book. But right now, we're just going to try and see what we can fucking do with this, because I just wanted to see if I could actually get it to work. That's the number one thing, is like, can I actually get this to compile? Can I actually get it to work? Because like, if I, if I can't, then this is just kind of a bust, But like, yeah, still, I mean, it's still worth it. I'm having fun doing it. I have no idea. I got really excited. I kind of wanted to fucking just see what I could do. So we're just gonna do some, we're just gonna do some random shit. So I'm just gonna type out some code here, and you guys have seen some random videos. Probably you've seen the power save video. The Minecraft video is going to do a good job explaining a lot of this stuff. But, while we're in it and while we're actually doing it, I'm not trying to, I guess, teach you guys like programming or anything like that. I'd love to. I'm going to try my best to kind of explain so you get a general vicinity of what's going on. But like right now, like what I would normally do is, I know that this unsigned is just an unsigned integer. It could be anything that, and especially in these old machines, you have to be very specific with what type of variable that we're going to do. I don't know how much C syntax you know, but in C, you always have to say, I'm going to make this type of variable, whether it's a float, an unsigned integer, a signed integer, and a 32-bit unsigned integer, a 16-bit unsigned integer, or anything like that. You have to let the compiler know what you're making and what you're initializing, so that way your compiler can understand it a little bit better. And I know that this is a bitwise shift to the right by 1 bit. So we're going to take whatever y is, and we're going to shift it by 1 bit. That's my understanding of it. And then we're going to take the row half. So whatever y was shifted by 1, we're going to take that, and we're going to multiply it by 80. Why 80? Because 80 is the column. So we have 80 pixels here, and then I think it's 640 here. I think it's 640 by 80, if I'm not mistaken. Sorry, 640, so bytes per row is 80, sorry. So 640 by 200, and then if you, and then you get 80 bytes per row, which means that we have per row and column, we can assign 80 bytes or 80 bits of information or something like that, and a byte is 8 bits. So pretty cool stuff. And then basically we have 640 pixels, 8 bits per byte, which is 80 bytes per scan line. And a scan line is just a, when it draws this, see this byte, this thing here, for example, it's just drawing it. That's the best thing. I mean, I'm no master at this right now. I'm just kind of fucking around. I'm just trying to see if I can get something to work, and then I'm really gonna like get balls deep into this shit and try to learn it as best I can. And then maybe when we come back to it, we can explain it a little bit better. But the number one thing I like to do is I want to let you guys know that this is a channel where we're just gonna fucking explore. We're gonna see what's going on. I want you guys. I chose this angle because I want you guys to feel like you're just kind of like hanging out with me, and you're just kind of like saying, you know what, fuck it, like, what's he up to today? You know, something like that. But I also want you guys to feel that like you can do it too. You know, like I just found this random thing in my grandparents' basement, and do I need to be trying to learn how to program in C or do all this other fun crap? No, but is it fun? Hell yeah, why not? I don't know. I want to get better at learning C, learning C++, hardware integration. I do a lot of embedded work, especially in the RF industry for reverse engineering malware, creating specific malware type of attacks. Specifically, I have to do a lot of eCPRI, which is the Enhanced Comic Public Radio Interface, and that goes through the front hall of a open. So open is just meaning, open means open to the internet, so the radio access network is now open to the internet. That's what Open RAN is, or ORAN, as the cool cats call it. But I do a lot of programming with that, and I deal with a lot of like
Hacker Man. He's the most powerful hacker of all time.
what did I do? Oh, what do you mean? Oh, crank this fucking hob, dude. Uh-oh. Alright, so it's me, Doc Mott's here, or whatever, integrated Mod, whatever the hell you want to call it. Alright, so let's go through what actually happened. So basically, C drive, not reading. It's not working. So I was like, oh crap, what's going on here? And I was like, oh, I can't, like, I don't know why it's not writing to the C drive. It can't link, it can't access certain files into the C drive. The directory, like, you know, file printer wasn't working. So I was like, screw it. What's going on? And it led me to this. Alright guys, what's going on? A little impromptu here. Just finished a workout, and while I was working out, I was like, oh my god, the card's not seated right. So, let's try running dir. Okay, that's good. Sometimes it takes a little bit to run dir. The card was a little propped out, so I think it actually does have to do something with that. And it would make sense why it partially reads, and then when it gets to, you know, an earlier address or an earlier sector within the fake hard drive. Yeah, see, look at that. All right, let's run. Okay. Okay. Now let's compile it. Actually, let's run it. All right, there it goes. It's linking now. What would you fucking look at that? Holy shit. It fucking, it did something. I don't know if that worked.
Insert cash or select payment type.
Boom, bam, bop, bada bop, boom, pow.
The pencil. Alright guys, well, thanks for watching. Next time we're gonna figure out how to draw a hell of a fucking pixel and see what happens. Yeah, I completely fucked up the C drive. So we're gonna have to figure out a better way to test all this out before we take it to the hardware. See you next time.
Skip it up and down up.